Today we're going to take a look at the power rule. So we've been working on rate of change and yesterday derivatives, which are just generic formulas for rate of change. And today we're going to try to see if we can come up with some shortcuts that we can use when taking the derivative of a polynomial. So up first, the very first question says, using the formula f prime of x is the limit as h approaches 0 of f of x plus h minus f of x over h. Determine the derivative of each of the following. That is what we did yesterday. So I would recommend that you pause the video and try it yourself, but I will walk you through it in case you don't remember what to do. So I need f of x plus h and f of x. My first function here is just a of x equals 10. So I am going to use a of x as f of x. So my f of x is just going to be the number 10. When I go to do f of x plus h, we are really doing a of x plus h. Now, you'll notice there is nowhere for us to sub in anything, right? There's no x here, right? So I don't have anywhere to put the x plus h. So f of x plus h is actually just 10, right? There was nowhere for us to substitute anything in. So when I go to do my formula for the derivative, we're going to do f prime of x because we have our function written in function notation. I could actually do a prime of x to match the question that we have. It is the limit as h approaches 0 of f of x plus h, which I'm not going to rewrite the formula down since it is here. So f of x plus h was just 10, and then minus f of x, which is also 10, and then divided by h. Now, we said before, our goal when we're doing this is to see if we can find a way to cancel out that h on the bottom, because as h approaches 0, we end up dividing by 0, and that's not good. So I am going to see if we can simplify that numerator a little. So 10 take away 10 is 0. So I have the limit as h approaches 0 of 0 divided by h. Now I don't have an h in the numerator to cancel with, but 0 divided by anything is 0, right? 0 divided by 2 is 0. 0 divided by 10 is 0. So 0 divided by h is 0. You'll notice we don't have an h anymore because 0 divided by h just gave me 0. So as h approaches 0, I don't have an h left. This whole thing is just going to equal what's in my bracket, which is 0. So the derivative of a of x, a prime of x, just equals 0. We're going to do the same thing for b of x. So I'm going to do f of x. That's just going to be my b of x, which is x. And then my f of x plus h. We're going to do, everywhere I see an x, we're going to put in x plus h. So I'm going to take out this x, and in its place, we're going to put in what's in the bracket, which is x plus h. So this just equals x plus h. There's nothing to simplify there. So when I go to do my derivative of b, or b prime of x, it is the limit as h approaches 0 of f of x plus h minus f of x, or b of x plus h minus b of x. So I am just going to substitute in. I'm going to say it's the limit as h approaches 0 of, well, f of x plus h is x plus h. I don't really need that to go in a bracket, right? We're not multiplying by anything. We're not dividing by anything other than eventually that h. We don't have a negative in front, so I don't really need to protect that with a bracket. And then we're taking away f of x, which is x. And then that is still over h. So as we mentioned in the previous question, our goal is to get rid of that h. So it would be nice if we could reduce it with something in the numerator. So I'm going to simplify my numerator. So I have the limit as h approaches 0 of x plus h minus x. The two x's are like terms, so x minus x is just 0. And then I'm left with h in the numerator. and we have an h in our denominator. So those are going to reduce. We can divide top and bottom by h, and that actually is just going to leave me with 1, right? H divided by h is 1. So I have the limit as h approaches 0 of 1. Now, same issue we had last time. There is no h for me to have approach 0, so this actually just equals 1. So b prime of x equals 1. Okay, so the question number 2 asks us to take what we just did and fill in the table below. So you'll notice there's a whole bunch of functions. I've calculated the derivatives of a lot of them for you. We've got a of x equals 10. That was our very first one, which the derivative is 0. So a prime of x was 0. And then b of x was x. That was the other one that we just did. So b prime of x equals 1. Okay, so what I'm going to ask you to do is see if you can answer part C. So part C says 2 of the derivatives in the table above are incorrect. Identify which ones are incorrect and explain in words what you think is wrong with each one. So I haven't told you what the shortcut is, but what I'm going to ask you to do is look at the functions, look at their derivatives. What do you notice? Do you notice anything, right? Some of them are just numbers. Some of them have x's, some have x squareds, some have x cubes, some have higher exponents than that, like x to the 4, to the 5, to the 6. I want you to look at the functions, look at the derivatives, see what you notice, and then make a hypothesis. Which ones do you think are incorrect? So that is something that I would like you to discuss, right? And then once you've come up with an idea, you can watch the next video.